everybody, this will be the last video and the last lesson that we're going to do. First off, thank you for cooperation and trying during these hard times and figuring everything out and kind of self-teaching and doing your best to watch the videos and piece it together. So this is the last thing you'll have to do is today's assignment. Everything else should be open at the moment, so go ahead and do everything you haven't done yet. If it's not open, let me know, but it should be. Everything will be open until Friday, and that's when everything is due. Grades will be posted then soon after once we get them all in. Again, this stuff can only help you, so please do take advantage of the situation and do your best with everything. I have one more little topic I want to talk about. It's very short. You're going to have like 3 problems to do, and they take half a second to do. Okay, so today's lesson won't be hard. The video is probably going to be super short too. I just wanted you to be at least exposed to this before you moved on. So today we're talking about this thing called scatter plot, but first it kind of builds on, we're still in like statistics and data and stuff. So if you're looking at the sheet right now, which you should be, because it'll help, at the top it says 2 variable data is a collection of paired variable values. Alright, well, if you can think of a paired variable value as like an ordered pair, has an x and a y. You got 3 graphs up here, and all of them have like a y-axis and an x-axis. Okay, but in scatter plots, the x-axis isn't just an x-axis, typically represents something. And same with the y. So if you look at the bottom of the page there, this 2 variable data is comparing 7 different cities on the planet in the northern hemisphere. So it compares 7 cities, and it compares their latitude, so where they are, north, south, and their average annual temperature to see if there's a pattern there. So what 2 variable scatter plots can allow you to do is check for patterns across data. So what you do is you kind of plot them and then see if they can map something or graph something. And then we talk about this idea of correlation, where maybe one thing correlates or goes along with another. So for instance, correlation, the definition on your page, is a measure of the strength and direction of a relationship between 2 variables. Basically, it means that they either increase together or they decrease together. And if they don't do either, they're unrelated. So here we have 3 kinds of correlation. Okay, so this one is positive correlation. So as the x is increasing, so is the y. It's going in a positive direction. This is negative correlation. So as the x is increasing, the y is decreasing. So it's like a negative line. Right? So if the slope was -1, you can kind of imagine that. This is a positive line. That's a negative line. But this seemingly random scatter here is no correlation. Again, this is positive correlation, negative correlation, and the last is no correlation. So if it's kind of scattered everywhere, there's no relationship there. If it looks like it's forming a positive line, it's positive. If it looks like it's forming a negative line, negative sloping line, then it's negative. Positive, negative, and random aren't new ideas, but this idea that the 2 sets of data are correlated is new. And correlated means paired together, or they go along with one another, or they're connected in some sort. Okay. I'll show you example 1 here to kind of show you what a problem will look like, or would look like, I guess. I'm just going to draw the graph. I'm not going to draw the whole table and list it all out. Now down here is latitude, and then across the side here is average annual temperature. So our y-axis is average annual temperature, and our x-axis is latitude. It goes up, I think, it's up at 10, 20, 30, 40, 50, 60, something like that, 80, and this one goes up to 50, 55, I think. So 10, 20, all right, not a perfect graph, but close enough. So what you do is you look at the cities. Now Bangkok to start, its latitude is 13.7 degrees north. Again, you don't really have to use, in this case, the measurements like degree north, degrees Fahrenheit, because the graph is kind of already set up that way. Okay, so the first table here is our x values. First column here is our x values. Second column is our y values. So for Bangkok, you go 13.7, 82.6 the way up here. Okay. This is just like plotting an ordered pair. So you've done this a bunch. It just looks a little different. And 30 and 70.1. 71.4, I'm sorry. 51.5. I don't want to miss that. Okay. So all I'm doing here is plotting all my ordered pairs. That's a little off. As best I can. Now, I know that it's not perfect. That's okay. And 77. So go ahead and do this as well. Your paper should look something like this. 49, 49. So okay. Now I'm not trying to draw a line in between them all. I'm not looking for that. If we were still in school and we were learning, that would be the next step probably. But now it's not the step we want to do. All we want to do, you see there's a blank there, it says the variables are blank correlated. We have to determine, are they positively, negatively, or not correlated? And imagine there's not a lot of points, but that's okay. Because imagine they were all filled in, right? That would kind of give us a line there. And I think that line is kind of pointed, sloping downward. So I would say they would be negatively correlated. So again, the process is plot the points. Are they positive? Is the line they make positive, negative, or they don't make a line at all? And then just tell me that one of those three. Okay? Now, the next page looks a little more complicated, but it's not that bad. It's what's called the correlation coefficient of a linear fit. Now, what that means is, again, don't get bogged down with all the math words. Basically, all it means is how tight is the line that the data creates. So, is it super loose and the points are just like everywhere? And let me draw these 4 examples right here to kind of give you examples. So the paper gives you 4 charts just like that. It gives you one like this. All right. Gives you 4 dots Oh, barely see it. Let me see if I can get a blue marker. Let me see if that makes it any difference. Oh yeah, it's much better. Okay, so that's kind of what your paper looks like. I will get back to the paragraph ahead, but I just want to kind of compare these four. So this is obviously a negative slope. It's going down. Positive slope. This is also a negative slope, but again, like I said, mentioned, the line isn't as tight. The dots are a little looser, a little more spread out. This one, as well, they're a little more spread out, but it's a positive slope. So there's two kinds of correlation, actually. There's strong and weak. So this is a strong. This one's also strong, weak, weak. Okay? But this one here is a strong, pointing downward, negative. This is a strong, positive. This is a weak, negative, because it's going down. And this is going up, so this is a weak. I don't know if y'all can hear the leaf blower outside. I hope you can't. That'd be bad. Okay. So there's this idea of what's called a correlation coefficient. We've heard the term coefficient before. It's it's the number attached to the x value, right? It's the number attached to the variable. The correlation coefficient just helps us know how strong or weak the correlation is. How strong, how close together or far apart the dots are when they form the line. And so when you have a strong correlation, use all my right words here. A strong correlation either way, it's going to be close to 1 or negative 1. So negative, it's going to be close to negative 1. There's a little box there in your paper. So a strong positive correlation is going to be close to 1. A weak negative correlation between negative 1 and 0. And a weak positive correlation follows the same pattern between 0 and 1. Again, these are fill-in-the-blank notes, okay? Fill-in-the-blank notes here. So if you have a strong negative correlation, you're really close to negative 1. Strong positive correlation is really close to 1. Weak negative correlation, so again, the line is not as condensed like this one. It's between negative 1 and 0, so maybe negative half, negative 0.5, something like that. Weak positive correlation is between 0 and 1, so maybe a half. So, for what I want you to do, again, it's a short video, there's only 4 problems down there. I'll do problem A. I should have left it up there. But look back on that page from before, just go ahead and scroll up. If you're on your Chromebook, which hopefully you are, look at that graph we just drew. That's what part A wants you to do, is look at that graph we just drew, and it wants you to assign one of these to it. It wants you to say, okay, is R, which is our correlation coefficient, is it strong or weak? Or no correlation? We said it was negatively correlated, so it's got to be one of the negative options. That leaves us with negative 1 or negative a half. That line looks pretty close together. I could pretty much draw a line through it. It's not all spread out all over the place. So I would say that's a strong negative correlation. So we would use -1 there. So for B, C, and D, I mean, you just write -1 right next to A. For B, C, and D, right below it, there's some room there. Just type the number you think works. Your options are in the example instructions. -1, -0.5, 0, 0.5, and 1. So just underneath B, assign one of those numbers to B, C, and D. Again, everything is open. If it's not for you, let me know. It's a problem. Thank you again for all your hard work through all this craziness, and thanks again for a good first semester. As a teacher, half of it was crazy, but it was still, the 9 weeks we had was still fun nonetheless. I'll hopefully see you next year. Swing by, say hi, and I hope you guys have a safe summer if I don't talk to you, and I'll see you guys soon.